Hello and welcome back again. Starting chapter 4, finally. It has been about 2 weeks since I ever recorded anything or added any new thing to the English course, because in case you have noticed or not, I have started recording actually not chapter, I have started recording the entire course again, but using the Arabic language. That's based on some of the audience. I have actually a big region of audience from the Arabic regions, and they have asked to produce the course using the Arabic language as an audio language instead of using or adding Arabic subtitles at the bottom of this very course. Anyway, I have started to record the Arabic course. I have finished chapter 1, recording chapter 1 entirely. It's been uploading starting yesterday for the actually you will find it in the Arabic playlist. Finally, we are here to start recording chapter 4 in the English course. Happy New Year, actually, because I haven't recorded anything in English in the English course in 2020. Last time I have recorded was in 2019. Now we are in 2020. Now things become more serious because we are in the same year of the exam release. Exam will be released next month at the end of February, at 24th of February. So be careful, start studying hard. We are now in January. I have been preparing in the past week, 2 weeks, for both of chapter 4 and 5, because we have 4 chapters left: 4, 5, 6 and 7. So 4 or 5 I've been preparing to record them together at the same time, and of course I'm sorry, consecutively, one after another, starting chapter 4 today, and after that I hope directly to start recording chapter 5 to make both of them available before the end of January. And February I will do my best to finish chapter 6 and 7, so everything will be available for you before the exam official date, which is February 24th. Okay, so chapter 4, the chapter that will make networks, building networks and studying CCNA joyful. Now you will have a chapter that will allow you to build an entire topology, consists of devices and devices like computers and servers, switches like layer 2 and layer 3 switches, which are also called multi-layer switches, also some models, different models of routers, all of them in the boundaries of the same topology and the same lab. Tons of commands and configuration will be applied all inside one lab to do many types of manipulations and redundancy and backups. All of these will be found in the technologies that will be discussed and practiced in chapter 4, which is the IP services. Okay, so starting chapter 4, first we will start with the first subject, which will be the DHCP. DHCP is a short for Dynamic Host Configuration Protocol, a protocol that you cannot build a network without it. Right now your network will function without DHCP, of course, but networks right now are not only 2 computers and 1 switch. Networks will right now are tens of devices. All of them requires IP addresses. This is something mandatory. We have talked about IP addresses. Every single device, no matter what type of the device is in the network, it requires IP address, both to speak and to listen in the network and share information with the network, whether sending or receiving. So DHCP comes for something extremely important and extremely useful, that you will never say that this protocol is useless or I can live and develop my network without DHCP. No, you will know why just in moments. What will DHCP do is this: imagine your network has a switch. Of course, its minimum requires 1 switch to connect my users. Let's say that they are 6 users or 6 end devices, no matter what type these end devices here, I don't care. Personal computers, servers, IP cameras, IP phones, printers, whatever. All of them are considered as end devices. All of them in the perspective of network are the same, called end devices, and all of them requires the same requirements to operate and function inside a network or inside a broadcast domain. So having like 6 devices, of course each one of these devices requires so far an IP address. An IP address is something useless without its subnet mask. And finally, just in case there was in the future a router that will lead me to another network, then definitely I would need a default gateway like we did in chapter 3 by adding default gateway to all the PCs that were used in the labs, whether in static route or OSPF in case you have watched chapter 3. So what does these 6 devices here requires? It requires IP address, subnet mask, and default gateway for all of them. So these are 3 requirements for a single device. Now they are 6 devices. That means that I have to type 18 line of information for all of these 6 devices in order to all of them operate on or function inside my network or to join my single broadcast domain or my single network. 6 devices may be good, maybe not. I must make sure that those 6 devices, none of them gets a duplicated IP address for any reason. I must not make a mistake. So in case I have gave IP address that ends with .1 in here, it must be .2 in here, .3, etc. But none of them for any reason gets .1 by mistake, because it will cause a catastrophe or a disaster in my network. Catastrophe is a big thing. A disaster in my network. So duplication is not allowed at all. This is something. The other thing is that I must type all the subnet masks correctly in case one of them had correct IP address but a different subnet mask. It will not operate in this network. It will be considered another network. After that, the default gateway, all of them must have a default gateway correctly copied and pasted or maybe typed symmetrically in all of them, just in case one of them has a missed IP default gateway or incorrect IP default gateway, it will not reach internet and other networks. So these are some headaches. I can avoid them just in case I had 2, 3, maybe even if it were 10 computers or 10 end devices, whatever. But networks these days, networks have tens of devices, not 10, tens of devices. You might be responsible for a small company and small to medium enterprise or a campus network. Okay, but they might have 50 devices at least. From 50 up to 200, it will be called a campus network. So 50 device multiplied by 3, that's 150 line of requirement and information that I must give to all these devices manually by myself. And notice this, I must access each device separately to add its 3 requirements: the IP, subnet mask, and default gateway. Can imagine the headache and time. And never do a mistake, never have a duplication, never have an incorrect subnet mask or incorrect default gateway. All of these must be applied correctly, so all of them must operate in the same network. So leave all that aside. Developers, of course, knowledge will never stop at a boundary or have an edge or an end. It will always develop. Scientists and developers will always develop technology to serve us well and to make much more less headache for us when we try to develop our network or operate it in the default criteria. DHCP came there to do something very simple and extremely useful, which it will dynamically, by dynamically I mean automatically, it will assign IP addresses, but not only IP addresses, it will also assign subnet masks, default gateways, and DNSs to every single end device in the network. End device in the network. I can do this for switches and routers, but for start, as a CCNA engineer, you will be required to do this for end devices only. It's very simple to do it for switches and DHCP and routers also. It's not something complicated. It's a single command to type it inside an interface. But for now, you will learn it and you must know how to do it correctly for end devices. So now what will happen now? What makes you say that it's extremely useful? What makes me say that is that 6 end devices, 10 end devices, 100 end device, I don't care. All of them are connected to a switch. After that, the switch is connected to a router. By the way, you will need a layer 3 device to do DHCP. Okay, I will just say that after a few minutes coming. You will need a layer 3 device. Layer 3 devices are only routers or multi-layer switches. I hope you have caught that. Okay, and say it before I do. Layer 3 devices are either routers or multi-layer switches. Using them and connecting all my network, no matter how much type or how much devices there are in the network, one router or one multi-layer switch is enough to be connected to them, and it will automatically do a fast and hidden negotiation between the router or the layer 3 device with all the end devices in the network and ask all of them which one requires IP addresses. Here are the IP addresses, subnet masks, and default gateways for all of you in matter of seconds, few seconds, and all your devices in the network will obtain those three mandatory requirements to join the network. Okay, and we will see exactly how will this be happened behind the scenes and will be practiced and configured by ourselves just in the lab in the upcoming videos. Okay, so one note, just please be careful. You are saying not only IP addresses but alongside with subnet masks and gateways and DNS. What is this? Please stop informing me about something new that you haven't mentioned before. Actually, DNS is something very simple to know in the CCNA, and it has been injected with the DHCP chapter. So DNS, what is DNS that the server, the DHCP, will also give to the devices? So my computer will now have DNS. What is DNS? So my computer will have it. And how to know this? You haven't talked anything about DNS in chapter 1. You have talked about IP subnet and gateway in chapter 1, but DNS, what is this? Actually that's because DNS is considered only as an IP service technology, but simply DNS is a short for the domain name server, which is type of service that will do translate the URL that you are typing, which is www.cisco.com, and enter in the browser. The router, the network do not understand letters and words. They do understand IP addresses. To make you reach this website, what you do is you can't just memorize the IP addresses of all the websites in the world. You have to memorize the IP address of cisco.com, google.com, youtube.com, Facebook, Twitter, etc. All of these, you must memorize them in your brain. So you must type all of the IP addresses in the browser whenever you wanted or required to show or to, to check or to log in a website, in one of these websites. This is not logical. I can't memorize these millions of numbers of IP addresses for all the sites that I've known, but I can memorize words in my language or English language or in a common language, which is the English right now. Okay, all websites are, most of them, written in English language. So you just write www.cisco.com. That's it. This is something that I can memorize. This is something simple for me. Just hit enter and that's it. I'm logged in the website. But what's happening behind the scenes is that the router doesn't understand words and cisco.com. They will get shocked. What is this? I do understand and route packets, and packets do contain IP addresses. They contain source and destination IP addresses. You are sending me words, so just before that DNS will come in and say to the packet, stop, you are requesting this URL. I will resolve it to its own and correct IP addresses and then forward the packet to the router. When the router receives the packet, it will see the destination IP address is an IP address of Facebook or Cisco.com. So it will reroute it to Cisco.com directly, and this is how you get the answer and show the website and log in whatever website that you desire or require. So this is the only function and the simple function of DNS. It's only that you resolve the URL to an IP address, and also vice versa. It does know that this IP address can be resolved back to www.cisco.com. This is something very simple that's called the reverse DNS. Reverse DNS do translate the exact thing of DNS but in reverse. DNS also works on UDP. In case you remember layer 4 technologies, then it do works on UDP port 53. It doesn't require TCP, something very simple. Also DNS are required to be very fast in responding because it doesn't make sense that I will type www.cisco.com, hit enter, and wait a few seconds for a three-way handshake and the connection orientation to be established between my device, my router, and the coupling router until reaching the DNS server, and between all of them after the TCP connection completed. After that, resolving process will start and complete, and then after all these seconds, maybe one entire minute, I have no idea, depends on the connection status and strength. Finally, the DNS server will serve me by resolving the URL to its correct IP address, and I will get to log into the IP address and to the website. Sorry. So UDP will do very good for the DNS. It will be more than enough for the DNS to operate quickly and fastly to serve us and to show us the website that we desire. So DNS also something mandatory for internet access only if in case you have a local network, just you want to connect some devices between them, or you want to connect your computer to an IP camera or maybe a printer. You don't need internet, or you don't have an internet connection, so DNS is not required. You can assign DNS, but DNS is not required. And by the way, when you want to assign DNS, there are some public, common, free DNS servers in the world. DNS, I'm saying server because it's a server in somewhere that's inside it. All the websites of the world are listed alongside with all their IP addresses, matching IP addresses. So this is what's inside a DNS. So what happens between me and them, I can make, there is a DNS server and there is also my device. So this type of relationship is called a server client relationship, because this is a DNS server and I'm a DNS client. Requirement requires for some resolving to happen, and it will be done by contacting this server. These servers that I'm talking about, there are a lot of public, free, common servers in the world that are available for anyone who wishes to enter the world of internet and just need some type of server, some DNS servers to resolve the required queries for him and make him allowed or help him enter a website and join the internet. So the most famous DNS server in the world, most of them maybe know it and familiar with it, is the 4.8.8.8.8, which is owned by google.com. It's available for all the world for free. Anyone wishes to acquire DNS services, it just can assign to its own computer the 4.8s, and that's it. It will be granted for all the will be granted for all the policies and all the benefits of this DNS server. Other DNS servers are, there is a backup IP address for this DNS server also. It was 8.8.4.4. I believe there is also some 4.2.2.2, and 2 years ago Google published, and with cooperation with the cloud, with another or new DNS server called with the Cloudflare Corporation, the 4.1s, which is much faster and using new technologies in the resolving. This is much faster than 4.8s. You can use 4.1s entirely free. You can use 4.8s also entirely free. Whatever you would like, it will do for you the job of resolving. So again, back to the DNS server. Back to the DHCP, sorry. I have talked a lot about DNS server and DHCP. You might be confused, but just know DNS is not something of your concern. Since you are a network engineer, leave this for the IT engineers. You care only about DHCP. Okay, but you must know what is DNS and what does it do. After that, go back to DHCP. We will go back to DHCP and we will not mention the function of DNS anymore. We will just assign the IP address of DNS, and that's it. DHCP again, some negotiations will happen in DHCP. I will talk about these negotiations in just 1 minute, or let's just talk about them right now. I don't think it should take another video. Okay, so again, back to DHCP. DHCP do assign informations, which are the 4 information that I've talked about: IP address, subnet mask, default gateway, and DNS, for all your devices dynamically or automatically, but this assignment will be for a specific amount of time. Of course, you will not reserve an IP address forever or for days or weeks, because you might leave this place or leave the workspace place that we are talking about, and you will not come back for days. So this specific IP address will be reserved for you, and this is also waste of IP addresses, okay, because we might only give a single pool or domain of IP addresses for some devices. So it will be the IP addresses, and those four informations will be assigned for your device but for a specific amount of time. By default it's 24 hours. You can minimize and maximize, you can change this, increase or decrease this duration of time. And also, after all of this has been done and happened, all your devices, all your clients has acquired the four informations, 50% sorry, after assignment, which means 12 hours after the assignment happens, the DHCP server will send some checks messages to your devices or to all the devices, checking if they are still online or not. If they are online, it's okay. It will continue to have the same informations, IP addresses, gateways, etc., and will continue to function. Just in case they were offline, then I know that these devices are offline. Maybe the employees or devices went home, that's it, and I can reuse the same IP addresses and informations to assign them to another new devices that requires new IP addresses. But just in case the IP addresses or the checks work correctly, they were applied from the client and the client is still there. So what I will do is that, what the DHCP server will do is that after 87.5% of the time, almost more than 20 hours after the assignment, it will apply the checks again. It will redo the checks again, just to check if the devices are still there or they have went offline. If they are still there, the informations are kept reserved for them. If they went offline, I will take these informations and I will give them to other new devices. So to achieve the DHCP service, some negotiation will happen between the DHCP server, which is in our case will be a router. We will not operate a real server. The router will do this function completely with no missings, okay, and my device will be the client. What will happen between them will be the upcoming. First, you must know that any computer in the world, once you operate your computer, your end device, at the first time after it boots, the first while after it boots up, it will require an IP address. So the Ethernet port of your device, after it operates, will automatically, without you do anything, will send a broadcast message. You know, broadcast messages do cause disasters in networks and cause storms, but this is something we cannot control using the DHCP, using the computers. But anyway, broadcast message for all the devices in the network advertising that I am here and I require an IP address, subnet mask and default gateway. So at first, this broadcast message is called the DHCP discover. So you will definitely face this question in the exam. What type of messages is the DHCP discover? Your correct answer must be it's a broadcast message. Broadcast messages do flow on all the interfaces of switches, all the switches in the network, but once a broadcast message have a clash with an interface of a router, which is this router in here, it will stop at this interface, because routers interfaces, each one of them is considered separated from each other, a separated broadcast domain. So once a broadcast message reaches this interface, it will stop in here. The router will listen to this interface broadcast message. If the router has the ability to help this message, it will reply to it. Otherwise it will drop it without any further disasters or storms. So for DHCP servers, after configuring this router as a DHCP server, first this message will go the DHCP discover, reaching a router. It will tell the router that please, I am requiring DHCP information to operate. If it was configured correctly, it will reply only this computer. So only means that the reply is is a unicast message, because unicasts go from one source to one destination only, without any other device in the network will have any idea what's happening between these two devices alone. So this second message, that is a unicast message, is called the DHCP offer. In the message, in this unicast message, the router will say, hello, I am a DHCP server. I am offering DHCP services and IP services in the network. I have heard that you are requesting these information, and me, from my side, I do give these information. I do offer them. Would you like some of them for you? Once the device or your computer will receive this message, it will resend for the second time a message called DHCP request. But guess what? Again, it's a discovery. It's a broadcast message again for the server, which is our router, or this server in here is a DHCP request saying that yes, since you are offering, I am officially requesting information of DHCP. Would you please offer me back for them, or reply me back with this information? For the fourth time, our router or server will reply to this computer a message called DHCP pack. Others call it DHCP reply message. In all of the cases, it's again a unicast message, once again carrying all the information that a client needs to assign for itself, which is IP address, subnet mask, default gateway, and optional the DNS server message. Okay, so by this method, or by all of this achieved, or these four messages, it's very important in the exam. In the previous exam, it always happened to face this type of questions. It will say that put the DHCP messages in order, and it will give you four randomized messages, which are: first the offer, second the pack, third the request, and fourth the discover. You must do them in order. Okay, you must align them in order. This is a question. Another type of question will be give the appropriate type of message, assign the appropriate type of message, or match the appropriate type of message for each message shown, and it will show you these four messages. And on the other side, it will show you broadcast, unicast, broadcast, unicast. So you must know which one is a broadcast, which other one is unicast. Whatever goes from client to server, this is a broadcast. Whatever replies from the server or the router to the client back, this is a unicast message. This is another type of messages you can do, or another type of questions that you will face in the exam. So this is how you make use of knowing the negotiation that will happen between a DHCP server and the client. Also, it will ask you about the percentage of times that breach checks will happen. First, after 50% of time. Second, after 87.5% of time. And this time by default is 24 hours. You can change it. Mostly, and logically making sense, all of the companies do make it according to their shift duration time, like 8 hours, because morning shift starts from 8 a.m. in the morning, ends up at 4 p.m. in the afternoon. So the DHCP server of the company will have a duration of only 8 hours. After the 8 hours, all the employees will close their devices, go to their homes, and the DHCP server will find that all the employees are offline. So I will take and collect all my IP addresses again for myself, just in case any new employees came and requested new IP addresses. I will assign them back the new IP addresses for anyone. The DHCP server will never do duplication. It will never be mistaken. It's a technology router that will do it correctly. You will see all of this by yourself and practice it in the upcoming video. So stay tuned with me. In the upcoming video, we will start to practice the DHCP server and do the hands-on lab. Thank you for watching and your time, and see you in the upcoming video.